mixture problems, not in yellow. Mixture problems are the ones that sometimes students get hung up on most. And remember, and part of that's because there's not a nice formula, like distance equals rate times time, or I equals PRT, or perimeter is 2 times the length plus 2 times the width. Okay. But if we talk ourselves through what's going on, we can figure out our own sort of formula or approach to these. Maybe I have 5 quarters in my pocket. How much money do I have? Okay, students tell me $1.25. Then I say, well, how did we get $1.25? Well, we have 5 quarters, and each quarter is worth 25 cents. So 5 times 25 cents is $1.25. Maybe I have 9 $5 bills. So it's 5. How much money do I have? Well, I have $45. Let's say, how did we get $45? We have 9 of them, and they're $5 each. Okay. Remember, mixture isn't just money problems. It could be stamps, it could be coins, it could be I forgot to pack the cooler for the ball game today, and so I have to run to Dillon's and get some fruit. And it says the oranges are, probably shouldn't have picked oranges with an O, but that's okay. Let's say they're on sale today and they're 30 cents each. Okay. Well, there's 5 of us, so I'm going to need to buy 5 oranges. And so if I'm not taking tax into consideration, I need 5. Ooh, no idea what I was writing there. Times 30 cents each. So that will cost me $1.50. So then I go to my room and I find my jar full of change, and I have a jar full of nickels. And so I stick my hand in the jar of nickels and I grab a handful of nickels. So I have no idea how many I have in my hand. And so then I say, well, how much money am I holding? What expression represents? When I ask how much money am I holding, I can't tell you $1 or 45 cents or $3.35. I have to just give you an expression that would describe how much it is depending on what N ends up being. So if I have N nickels, and nickels are 5 cents a piece, that means I have 0.05 times N dollars. That stupid box won't go away. Okay. Now the nice thing about change is for nickels, if you want to use the decimal representation, you can. If you say, I'm just going to use 5 for 5 cents, that's fine, as long as everything in your entire equation that you create has the decimal in it, or everything in the entire equation you create has no decimal in it. Okay, you can't mix dollars in one line and cents in the other. It needs to all be in terms of dollars or all in terms of cents. Okay, but either is fine. What we have here then is, again, not a nice formula like distance equals rate times time. But if I want to know the total value or the total cost of something, I take how many or how much, pretend how many is 2 words. Okay. So I had 5 quarters, 9 fives, 5 oranges, and nickels. How many or how much? Times the unit cost or value. I'll say value or cost because that's the order I wrote it on the right. And that product gives me the total value or cost. Now all of these problems here are how many? I had 9, I had 5, I had 5, I had N. But how much, this also applies if we're dealing with mixture like a saline solution, or our chemistry problems, other ones with hydrochloric acid. It doesn't have to be 5 or 9 or 6 or 3 of them. It could be 4.8 liters of gasoline. It could be 1.2 gallons of hydrochloric acid. Okay, so that's the how much. Also, if you're dealing with a chemistry problem, instead of a unit cost or value, you're going to have your concentration. So 20% saline solution, 50% saline solution, and don't forget to write them as decimals. Okay, just like we write our decimal values here when it applies. So if we take how many or how much, and we multiply it by the unit cost, value, or concentration, that product gives us the total value or total cost. Okay, and that's for all of the mixture problems. There was some more I wanted to talk about, but maybe we'll save that for the next video.